The last section in chapter 1 is lesson 10, comparing real numbers, and it's on page 89. This will be easier since we have calculators, but you do need to have this picture pretty much memorized. So if we look, natural numbers are these ones in the middle. That's all the positive numbers with no decimals. Positive, no decimals, that's natural. Whole numbers are all of the natural numbers, but also including 0. So 10 is a natural number and a whole number. 0 is only a whole number and integer and rational. It's not a natural number. Okay, then we have outside of that is integers. Integers include natural numbers, so everything in the green is an integer. Everything in the yellow is an integer, but it also includes negative numbers. So still no decimals. Integers, whole numbers, natural numbers have no decimals. Natural is only positives. Whole is positives and 0. Integers is positives, negatives, and 0. Okay, so -8 would be an integer, but not a natural number. 9 would be a natural, whole, and integer. Okay, and then rational is everything in natural, everything in whole, everything in integer, and then it also includes anything that you can write as a fraction. So repeating decimals, terminating decimals, and then like percentages and fractions that stop if you divide, like for example, -3 divided by 4 gives me -0.75. And so that's a terminating decimal and it would be a rational number. Irrational numbers are none of these. So almost every number is not going to be irrational. Irrational includes numbers that the decimal does not repeat. So if I were to put the square root of 3 in my calculator, it would be a number that keeps repeating forever and ever. It keeps going, but never repeats. So none of these numbers repeat again and again and again. So it says 1, 2, 1, 2, 3, 1, 2, 3, 4. So there's never a time where it starts saying 2, 2, 2, 2 or 2, 1, 2, 1, 2, 1. It's not repeating. That means it's irrational. Okay, and then real numbers include everything that you know. Any number that you know is a real number. Okay, so if I want to know what 10 is a natural number, whole number, integer, rational number, and real number. 0 is a whole number, integer, rational number, and real number. Okay. All right, so let's look at the guided practice on page 92 then. Number 1 says, name all of the sets of numbers to which each real number belongs. Okay, so if we look at this problem, or this number, the 0, 5 keeps repeating. Now, it keeps going forever, but because it repeats, first of all, it's got a decimal. Because it's a decimal, it is not a natural, it's not a whole, it's not an integer. So the only thing this could be is a rational number or an irrational number. And they're all real numbers here. Okay, so because it repeats, that makes it rational. And so it would be a rational number, and I could also write real number if I wanted. Okay, if I do the square root of 64, I would get 8. So this is the same thing as -8. Negatives are not natural and not whole. They are integers, and if they're integers, then they're also rational. So integer, I would write integer, because integers include negatives with no decimal, and I would write rational, and I could write real if I want. Okay, The square root of 17 would give me 4.12311056. Okay, because this one does not repeat. It keeps going forever and ever, but it does not repeat. This is an irrational number. So I could put irrational and real if I wanted to put real. Okay, so irrational number does not repeat. All right, so if we look at numbers 4, 5, and 6, it says fill in each circle with less than, greater than, or equal to make a true statement. So I want to know, is the square root of 15 less than, greater than, or equal to 3.5? And again, you have calculators. So put the square root of 15 in the calculator and you would get 3.8729. 3.8729 is greater than 3.5, and so I would put greater than. Number 5, same thing. If they give you a radical, put it in the calculator. The square root of 2.25 is 1.5. 150 as a decimal, this percentage is 1.5 also. So these two are equal to each other. The square root of 6.2 is 2.489, and it will keep going. This one is 2.4, and the 4 repeats because it has the bar. That means it repeats forever. But 2.48 is bigger than 2.44. Okay, so I would put greater than here. 2.48 is bigger than 2.44. So I'm putting greater than. All right, number 7 says order the set from least to greatest. So I want the smallest to the biggest. Least to greatest, and then verify your answer by graphing it on a number line. Okay, so again, I'm going to change all of these to decimals so that I can compare them easier. The square root of 5 in the calculator is 2.236, and it keeps going, but I only need a few places. 220% is the same as 2.20. 2.25 is already a decimal. 2.2 with a bar means that the 2 keeps repeating. Okay, so now I'm going to compare them. So if I compare these 4 numbers, the smallest is 2.20 because this is 2.23, 2.20, 2.25, 2.22. So 0 is smallest, then 2 is the next smallest, then 3, then 5. And so when I put them in order, this one is the smallest, so I would write 220%. This one is the next smallest, so I would write 2.2 with a bar. And then the square root of 5 is the next smallest, so I would put square root of 5, and 2.25 is the last one. And I'm going to write it with the brackets around it because that's how I would write a set. Then it said to verify on a number line, so I'm going to draw myself a number line. And they gave you a number line in the book, but if they don't give you a number line, just draw yourself a number line with these decimals on the number line. So I have 2.2, 2.22, 2.23, 2.24, etc., etc. So I put them on a number line so that I can see this one is the smallest, next, next, next. Okay, and the last one says, the formula A equals the square root of all of these variables can be used to find the area of a triangle. The variables A, B, and C are the side measures, and S is 1/2 the perimeter. Use the formula to find the area of a triangle with side lengths of 7 centimeters, 9 centimeters, and 10 centimeters. So it already says A, B, and C are the side measures. Okay, so when I put those numbers in, I put A, B, and C where the formula said to put them. Okay, but it also said S is 1/2 of the perimeter. So if it's a triangle, my perimeter is just adding up all the sides. So my perimeter is 7 plus 8 plus 10, which is 25, and half of that. So actually divided by 2 would give me 12.5. So this is 12.5. I wrote this wrong. Okay, so it would be the square root of 12.5, parentheses 12.5 minus 7, parentheses 12.5 minus 8, 12.5 minus 10. Okay, and then I would find those answers, and let me go ahead and put those in the calculator, because when I found the answer, it was not a right answer. So if I do, I'm just going to go ahead and put 12.5 parentheses 12.5 minus 7, close parentheses, parentheses 12.5 minus 8, close parentheses, open, 12.5 minus 10, close parentheses, press equals. So underneath this radical, all of this together, I would get the square root of 773. And then when I take the square root of 773, I would get about 28 centimeters squared for my area. Okay, and that's all you need to do on that one.